Hi class, welcome to exercise 4G, the cosine rule, where we continue with our extra complications of trig. Your examples and pre-learning today are example 12, finding side lengths using the cosine rule. And for this example, your pre-learning is question 2 in the new book and question 3 in the old book. And then we'll do example 13, which is finding an angle using the cosine rule. And your pre-learning for this example is question 3 in the new book and question 4 in the old book. And while I joke that it's making trig a little bit more complicated, I actually think following along with the formulas won't be that tough. So let's keep going with that. However, proving these things being true is difficult, but I'm leaving that for a challenge video at the end of this block. Anyhow, I'll see you in the introduction. Alright, let's start by drawing a triangle. And notice that the sides and angles are denoted just like we did for the sine rule, i.e. sides relate to the opposite angle. And as you know, today's lesson is about applying the cosine rule. So let's just state the cosine rule. And before I do that, let's remember that the sides and angles are labelled exactly like that on the triangle. Anyhow, the rule is c squared is equal to a squared plus b squared minus 2 times ab times cos of c. And I really think I should highlight that pink. And to state this in clear English, this means that the squared length of a side, c squared, is equal to the sum of both of the other sides squared, i.e. a squared plus b squared, minus 2 times both of the other side lengths, which is this minus 2 times ab, times the cosine of the opposite angle, which of course is that cos c. So in other words, that comes together to be c squared equals a squared plus b squared minus 2ab times cos of c. So if I'm trying to figure out the side length c, well, that's just equal to the square root of a squared plus b squared minus 2ab cos c. But when we're solving for angles, it helps if we manipulate that formula. So let's start off with the formula. And obviously we're looking for an angle here, so I'm going to start doing things to solve for c. So the first thing I'm going to do is move c to the other side. Okay, so that was just simply adding 2ab cos to both sides. And now I'm going to subtract c squared from both sides. And obviously we're solving for c, so let's divide both sides by ab, and we end up with cos of c is equal to a squared plus b squared minus c squared over 2ab. And I'm sure you recognize this, but this makes it easier because taking the inverse cosine, we end up with c is equal to inverse cosine of a squared plus b squared minus c squared over 2ab, where c is the angle we're interested in, and c is the opposite side to the angle, and ab are the two other sides. So if you remember the sine rule lesson, there was a few problems with obtuse angles. So what about obtuse angles with the cosine rule? So let's try cos of 120 degrees. Okay, let's put that in the calculator. You might not be able to see that, but that's negative 0.5. This is another hint for the unit circle. However, for today's class, it tells you that obtuse angles are not as tricky with cosine. And considering that cos of 120 is equal to minus 0.5, that means that inverse cos of minus a half equals 120 degrees. And you won't need to make a choice, unlike we had to do with sine. Okay, so that's all the ideas introduced. We'll move on to the next section in a second, but I do recommend that you pause the video now and do the building understanding questions in the new book, but that relates to questions 1 and 2 in the old book. Because we are coming up against these new ideas, it's definitely worth the building understanding sections. I think once you understand how to use this formula, what we're going to do today will become quite simple for you. Anyhow, I'll see you in that next section. So when finding a side length with the cosine rule, the first step is to label your triangle so you know which side is opposite to each other. But more importantly, which side is opposite to each angle. So let's just draw one of those triangles. And this is exactly how you should label it. So once you've done that, you just need to then fill in the blanks and apply the formula, which I'm sure will be quite easy considering you've done the building understanding questions. And once you've done that, you're going to solve for the unknown. Alright, let's have a go at one of these in example 12. where we have a triangle that has 3 centimeters on one side, 2 centimeters on another, and they're separated by an angle of 102 degrees. That degrees looks like a 0, doesn't it? And now they want us to find the third length of this triangle. So the first thing I'm going to do is label the triangle so the formula gets easy. So marking in our unknown side as C and the opposite angle as C, then the other two angles are A and B. It actually won't matter which one's A or B in that case, as long as C and C are the same. But anyhow, so for the formula, C squared equals A squared plus B squared minus 2AB times cos of C. Our A is going to equal 3 centimeters, B will be 2 centimeters, and capital C will be 102 degrees. So subbing those numbers back into the formula, the side we're looking for, C, the square of that is going to equal 3 squared plus 2 squared minus 2 times 3 times 2 times cos of 102 degrees. So obviously 3 squared plus 2 squared is 13, and 2 times 3 times 2 is 12. So C is going to have to equal the square root of all that on the right there. So let's bang that in the calculator. So that's 3.9363. So rounding off to 2 decimal places, we get C is equal to 3.94. So hopefully you see that as pretty straightforward. So let's pause the video now and do questions 2 in the new book and questions 3 in the old book. And then you can come back for the next section. Okay, just like finding a side length, when you find an angle using the cosine rule, it's really important that you label the triangle so you can apply the formula correctly. And then once you've labelled it correctly, cos of the angle C is going to equal A squared plus B squared minus C squared, all divided by 2AB. And then applying the inverse function, C will equal inverse cos of A squared plus B squared minus C squared, all over 2AB. Also remember that there's no choice for an obtuse angle. For inverse cos of x, if x is less than 0, then the angle will be obtuse. But it is important that you note that x can't be less than -1 or greater than 1. In other words, x has to be between -1 and 1, inclusive, for inverse cos of x to make any sense. Well, any real sense, and one day you might know what I meant there. Anyhow, let's move on to example 13. Where we have a triangle that has sides of 13, 12, and 8 millimeters. And we're asked to find the angle theta. So if you remember our formula, that means our angle C is going to equal the inverse cos of A squared plus B squared minus C squared, all over 2AB. And in this case, the angle C will equal theta. Little c will be 8, and A can be 12 and B can be 13. It really doesn't matter which one's A and which one's B, okay? You can try that out yourself in the formula. Anyhow, let's sub those values in. So now we've got theta equals inverse cos of 12 squared plus 13 squared minus 8 squared, all over 2 times 12 times 13. Now, depending on how good your calculator is, you might not want to type that in that way, because it's very easy for it to not get the fractions right. So just for the sake of that, I'm going to work out the numerator and the denominator separately. So 12 squared plus 13 squared minus 8 squared is, calculator please, 249. So let me write that out. And 2 times 12 times 13 is, I'm going to need a calculator again, is 312. But let me just write that out. So we now got theta is equal to the inverse cos of 249 divided by 312. And let's bang that in the calculator. So that is 37.05. So to 2 decimal places, we don't round up that 5. So theta is equal to 37.05. Okay, so there's lots of room for complication there. But I also think that if you stick to the formula and label your triangles correctly, it won't be too difficult. So right about now, you should pause that video and do questions 3 in the new book and questions 4 in the old book. And when you come back, we can summarize this lesson. So we've been applying the cosine rule, and we haven't learned why it is true. But we will be proving why the rule is true in the challenges. Just like the sine rule. Also like the sine rule, we can see that 3 measurements of a triangle will give us enough information to be able to figure out any other measurement on this triangle. Alright, so in this lesson, a successful student will know that the cosine rule relates to one angle and three sides of any triangle, and be able to use the cosine rule to find any angle given all three sides, or a third side of a triangle given two sides and the included angle. Alright, good luck with that. Have fun with all your pre-learning, and I'll see you in the next lesson. Bye.